An angle is a measure of a turn or rotation. Imagine standing in one spot and turning around in a circle. The amount you turn is your angle. Angles help us describe the direction things are pointing, and they're everywhere in real life, from the corners of buildings to scoring the perfect free kick in football. To measure angles, we use a tool called a protractor. It's a curved piece of plastic or metal marked with degrees, and we use it to measure how big or small an angle is. Here's how to use a protractor. Place the protractor's cross, the little hole or cross in the middle of the flat edge, on the corner of the angle you want to measure. Line up the bottom of the protractor with one of the lines of the angle. This is called the baseline. If the angle's line is too short, you can make it a bit longer to match up with the protractor. Look for the scale of degrees that has 0 on the line of the angle you're measuring. Read off the number where the other line crosses the protractor scale. That's your angle in degrees. There are different kinds of angles based on how big they are. Right angle, an angle that measures exactly 90 degrees, like the corner of a square or rectangle. Acute angle, an angle that is less than 90 degrees. Obtuse angle, an angle that is more than 90 degrees, but less than 180 degrees. Straight angle, an angle that is exactly 180 degrees. It looks like a straight line. Reflex angle, an angle that is more than 180 degrees, but less than 360 degrees. Sometimes, you might need to estimate the size of an angle without a protractor. You can do this by comparing it to angles you know. A right angle is easy to spot because it looks like the corner of a book. If an angle is smaller than a right angle, it's an acute angle. If it's larger than a right angle, but less than a straight line, it's an obtuse angle. Here's something cool about angles. Even if you make a picture bigger or smaller, the angle stays the same. If you draw a triangle on a small piece of paper and then make a giant version of the same triangle, the angles in both triangles will be exactly the same. Only the size of the triangle changes, not the angle. It's also important to understand the different types of lines and how they relate to angles. Horizontal lines. These go from left to right, just like the horizon, where the sky meets the land. Vertical lines. These go up and down. Perpendicular lines. These lines are at right angles to each other, like the corners of a piece of paper. Parallel lines. These lines go in the same direction and never meet, no matter how far they go. We mark parallel lines with arrowheads to show they always stay the same distance apart. Angles are everywhere in everyday life. Architects use angles to design buildings, and footballers use angles to kick the ball into the goal. Even when you cut a slice of cake, you're creating angles. Once you understand how angles work, you'll start to see them all around you. Understanding angles helps us describe how things are positioned and how they turn. Whether you're measuring angles with a protractor, estimating them by comparing to known angles, or recognizing parallel and perpendicular lines, angles are an important part of the world around us. Now you know how to measure, estimate, and identify angles with ease.